Thank you for joining me on this webinar about drainage water management. I am Keegan Kalt, the Executive Director with the Agricultural Drainage Management Coalition. This webinar is the fourth webinar in the series of six from the CTIC ADMC project. This project was funded by the EPA to help train ag consultants on the benefits of conservation drainage practices and to provide resources for those consultants to go back to help increase the adoption of these practices. Today you will learn about what drainage water management is, where it works, the benefits of drainage water management, control structures used for drainage water management, as well as the cost effectiveness of the practice itself. Stepping back, a little bit of background information on the Agricultural Drainage Management Coalition. We are an industry-led coalition, so a lot of the tile manufacturers and distributors are members, as well as the engineering groups that design these practices, the software support companies, the other ag industry members, as well as the drainage contractor organizations such as LICAs and the contractors themselves. ADMC's mission is to improve America's water quality and economics through managing drainage systems. So we look to find practical solutions, and then not only find those solutions, but find ways to speed up their implementation. Reviewing, in case you haven't seen all of the webinars as part of this series and only catching this one, just really quickly, the benefits of tile drainage, earlier planting dates in the spring, also better harvest conditions in the fall by drying that soil out, getting that seed bed ready to go for the spring planting, better harvest conditions. We reduce compaction by having that drainage in place instead of having the wet soils with the heavy harvesting equipment on it. That drier soil holds up much better, sets you up for a more successful spring the following year. Decreases in crop damage due to excessive moisture and precipitation. That excessive moisture and precipitation is one of the highest insurance claims, crop insurance claims every year through RMA. Improved nitrogen use efficiency with drainage. You can grow more crop with less nitrogen by utilizing drainage. It also decreases some of the variability about what would the best nitrogen application rate be on a given year when you have drainage in place. That artificial nitrogen fertilizer creation is one of the most energy intensive processes in agriculture. So it requires a lot of energy on that end. So by decreasing the amount of nitrogen needed to grow your crop, you improve the energy efficiency of your systems through drainage. Then next, all this leads to increased profitability, which also drives increases in the land values. However, there are unintended consequences with drainage. Drainage provides a pathway for dissolved nutrients to get from the field to our surface water bodies. So nutrients like nitrate, which are dissolved and carried by water, and dissolved phosphorus can leak through the tile systems, get into the tile systems and into the surface water bodies. These resource concerns are really at every level, the farm level. If you have livestock that are using that as a water source, or even a rural well system can be contaminated by nitrate. Locally, a lot of drinking water sources, the communities rely on either surface water bodies or shallow groundwater sources for their drinking waters in their communities. Des Moines Waterworks is one of the best scenarios about this, or best well-known cases about this, with their drinking water supply coming from the Raccoon and Des Moines rivers, which are both heavily ag-dominated watersheds and a tile-drained landscape. And there's resource concerns there of too high of nitrate concentrations in that water to be able to safely distribute to their customers. And then regionally, there's concerns wherever these streams end up outletting to finally, and these nutrients are transported there. You have concerns of Gulf of Mexico hypoxic zone, the TMDL in the Chesapeake Bay, the Western Lake Erie Basin, and the algal blooms are all cause for concern with dissolved nutrients. I really like showing this slide from Dr. Mike Castellano as well, that looks at nitrogen availability and also when our crop uses that nitrogen. So that red line represents the nitrate that's produced from our organic material in our soils that are there already. And when that gets converted from that mineral to from that organic form to the mineral form, uh, and then so it's available to the crop. And then the green line represents when our corn, soybean generally utilize that nitrogen. If those two peaks overlapped perfectly, well, we wouldn't be seeing the issues we see today with dissolved nutrients, but they do not. And so that time period in between those two peaks really represents when we're at risk for losing those nutrients uh, downstream and in our tile lines. So when we think about production in the environment, uh, the event of that, the conservation drainage really serves to kind of overlap those two purposes. So to get that production that we need the drainage, and then get the environmental outcomes that we want, we need some best management practices associated with that drainage. The conservation drainage practices that I typically work with, drainage water management, bioreactors, saturated buffers, sub-irrigation, and drainage water recycling, which is a new one off of sub-irrigation, constructed wetlands, sometimes referred to as water quality wetlands, and then some of the two-stage ditches that are starting to come online, as well as multi-purpose oxbows. So once again, today, we're going to be talking about drainage water management. There are two other webinars in this series discussing bioreactors and saturated buffers that are excellent resources, and I hope you watch those as well. So jumping into drainage water management, what is drainage water management? Well, it's a system where control structure is used to manage a drainage system's outlet height and to control the amount of water that's drained off the field and the timing of when that's drained out of the year. Think about it, we really don't need drainage 24/7, 365 days out of the year. There's really only windows that we really need drainage. Right now, most of our tile systems are being installed without a control mechanism. So we can't really turn them off at a given time. It's gravity fed systems 24/7, operate year round. But really, when we take a step back, there's times where we would actually benefit from holding water back up into the field, maybe make that water available to the crop. So we can utilize control structures to raise and lower that outlet volume height by basically stopping the flow or backing water up until that point, and then any excess water would drain over the top of the stop log and drain out of the system. So it gives us the ability to control that water table elevation, assuming that the water's there to control. Looking at the control structures that we use, right now, AgriDrain control structures are the most widely used structures for the practice. The structure on the left shows a cutout of it. See the stop ports there, the common section, so you have control of what that height is going to be. Typically, those 5 and 7-inch sections. Also, newer is the water gate on the right, and you can see how that water gate works in series with the water control structure. So the water gate structure is actually below the surface. It allows us the ability to control greater elevation differences from that control structure that sticks up out of the ground, so you can get in there and manipulate the stop log. Obviously, farmers aren't going to want to drive around a bunch of control structures out in the middle of the field, so you can utilize water gates back into the field, and they operate with a float system basically, and so you can start backing water up at the lower end with the water control structure, and once you get enough water backed up to those water gates, it'll close that float valve, and then water will start backing up behind it in series, and so you can gain about an extra foot of elevation control with each subsequent water gate that it's used. An exciting advancement in drainage water management is the development of these automated control structures that can be set up to be locally programmable, so you can set your schedule of when those stop gates are going to be open and closed based on the time of the year in the field, or you can actually even have a cellular communication with it set up right now where you can adjust it with your laptop or mobile phone. You can have different settings. These are really nice. One of the barriers to entry on this practice has been, farmers don't want to be out there managing, a dozen control structures that are going to be located at different spots that might be hard to get to. during times of year, especially when you need to change those elevations, after a big rain event. You don't want to have to be driving through a muddy field to get to your control structure. The automation allows you to do that remotely. Automation also gives you the added advantage of being able to add in a little bounce with the system where you get the big rain, that water comes up. You don't immediately have to release that. It's not going to cause crop damage right away. So you can actually hold on to that water for a little while, then open up those valves. And what that does is lets that water really soak into that soil system. If you think about years where it's really dry and you start seeing those cracks forming your soil, right? And then all of a sudden you get that big 2-inch rain. Well, those cracks are just basically macro pores that go straight down to your tile. So you might actually end up losing a lot of that water through the bottom end of your tile system before that soil has that opportunity to absorb it like a sponge. So automated structures can allow you to do that and take better advantage of those big rain events after it's been dry. So where does drainage water management work? It's really located in fields with slopes that are less than 1% grade. That doesn't mean that the entire field has to be less than 1%, but you need management zones within that field that meet that criteria. And obviously, the larger that management zone is, the more economical that the practice is going to be. So if you can get, 20 to 30 acre management zones operating off of one control structure, that's much more cost effective if you're only getting 2 to 5 acres. Once again, those water gates kind of expand how much control we can utilize with a single control structure. You also need to be able to hold that water table in place. So you need to be able to, have a high natural water table. You don't want it sandy on the bottom. You don't want to just lose all the water off the bottom end of this. Not only do you need the right topography and underlying soils, but you really need that drainage design to be installed thinking about drainage water management. Historically, we always kind of say this drainage water management works really well. The field is flat as a pancake. We know most of the fields aren't perfectly flat, though. Maybe it's a stack of pancakes. We have a little bit of change. That top stack of pancakes there is how we've traditionally installed our tile systems, going up and down the slopes. And that doesn't set up very well for water management because our main that we intercept with our control structure only gets very little control within that field where the laterals are going up and down the contours. Instead, we need to shift that 90 degrees and have our laterals run along the contours. That way we can control much more water with a single control structure as the main is going up and down the slope instead of across the slope. Controlled drainage, suitability and scalability. NRCS estimates there's about 30 million acres in just the Midwest alone that are suitable for this practice. Of that 30 million acres, we probably only have a couple 100,000 acres utilizing drainage water management right now. Ohio, it's probably one of the states leading in this. Through their H2 Ohio program, you can install drainage water management. The Western Lake Erie Basin, of course, is very concerned with drainage water reaching Lake Erie and causing algal blooms. So there's been a lot of focus paid to in Western Ohio, as well as Indiana. Iowa has the most suitable acres for this practice. Once again, it's kind of one of we need to have that tile installed properly to set us up to be able to utilize drainage water management. So if there's going to be areas of new tile going in, that's great to target. Otherwise, really flat fields that you happen to be able to get larger management zones are ways to get the practice on the ground. Benefits of drainage water management. This is one of the conservation drainage practices that I get to work with that can actually provide a return on investment to the farmers. You can see a 5 to 10% yield increase in the corn production. And this doesn't happen every given year, and I think we can actually improve the way we manage this to increase the likelihood of this happening. Um, the ideal scenario for this would be kind of the wet spring followed by the dry summer, where you would see the biggest yield boost for drainage water management compared to conventional drainage systems. You can set it up so you can get that drainage in the spring, but then start to think about holding water back once all the spring field operations are over, and you can follow kind of that rooting depth down to set your elevation point and really be able to hold that water back and hopefully get it to the crop when it needs it later in the summer. Also, with the advent of automated drainage water management, I think farmers can be much more prescriptive when looking at how to manage their field. They can really take into account what's happening in the next 2-week forecast, and it'll be easier for them to change their stop logs instead of just letting pulling the stop logs out, just letting everything drain and not being able to hold anything back. We've also set this practice up with ease in mind, keeping it easy for the farmers. And with the manual structures, we didn't want to tell the farmer that they're going to have to go out there and change stop logs 5 to 6 times a year, because that probably wasn't going to happen. And so they've really set it up to maybe change it, 3 to 4 times out of the given year. And that really doesn't give us as much control as maybe that we might get with automation. So if we're changing those stop logs more frequently, being more active and intentional with it, we will be much more likely to see those yield increases. On the water quality side of things, 33% average nitrate reduction is kind of the number that's out there. Studies have shown anywhere up to an 81% nitrate reduction. That nitrate reduction really happens with just decreasing the volume of water that's transported with your tile system. Same thing can be accomplished with having a shallower tile system. So instead of having your main at a 4-foot depth, if it's at 3 feet, instead, that's a 25% reduction in the potential flow volume coming out of that system. So the shallower tile systems, that might be an opportunity on landscapes that have a little bit more relief and where drainage water management won't work. But where you have a flat landscape and you can make drainage water management work, we can see that 33% load reduction. Phosphorus is a little bit more variable, but studies have shown up to a 50% insoluble phosphorus reduction. Probably more studies there need to be done to make sure we're locked in on how much phosphorus we're reducing by utilizing drainage water management, but it can be an effective practice in reducing those losses as well. And then we also have another benefit of drainage water management is the decreased variability in nitrogen use efficiency. And also, when we write nitrogen management plans for farmers, you kind of have to take into account all the weather systems that farmer might be facing and the nitrogen that you're going to lose throughout the year. With that, drainage water management really reduces that variability of what that optimum nitrogen rate would be. Dr. Mike Castellano has a presentation out there where he's showing up to a 75% reduction in variance of the agronomic optimum nitrogen rate by utilizing drainage water management. Then finally, there could be some benefits to seasonal flooding for wildlife. There's an initiative in Illinois to do that, to actually bring water up to the surface in some of these systems to provide some water for migratory birds. And that can be the case for other wildlife systems as well. I'm thinking about the design of these. We're really thinking about that control elevation in your control zone. So that control elevation is going to be that lowest elevation on the soil surface, looking at the topo maps. And so that whatever your lowest elevation point is, that's what you set your control elevation to be. Important to know where your tile is, though, to make sure that your main that you're sitting on actually is interacting with your control elevation. Also, then your control zone is going to be a maximum of 2 feet higher than what that control elevation is. Obviously, if you can kind of hone that in, be less than 2 feet, you get actually more control of that water within that system if that's only down to a foot, but that usually reduces the size of your actual control zones. one thing about drainage water management, it'd be nice if, ideally, like all your laterals line up, you put one control structure in there and can control your whole field with that one control structure. But nothing's ever ideal, right? So usually you're going to have multiple control zones in there. You have, in this instance, there's a control zone A, control zone B, where you have a couple different water level control devices that actually be able to operate that. But these are things that the designer can take into consideration when looking at the topo maps and the way that tile was installed in that field. Additional criteria to think about when we're trying to site these. You need to have that ability to hold that water table within 12 inches of the ground surface. That does not mean that you're holding that water within 12 inches of the ground surface year round. You want to maintain that design level, except for when you lower it for that crop root zone. So while that crop is actively growing, you do not need to have that managed to be within 12 inches. Also, you can lower it for field work and to make sure you have the ability to get out there and do what you need to do in the field. If there's adverse weather conditions where we're getting just slammed with big rainstorms, you can adjust that as well. NRCS allows that. Or if there needs to be maintenance involved, you can adjust that. One of the things that is being looked into is, typically right now with drainage water management, once that primary crop is harvested, you generally raise it up to that 12 inches within 12 inches of the ground surface right now through your operation and management plan with NRCS. But now, we're trying to incorporate more cover crops into the system as well. So what does that 12 inches, if you're maintaining that water table within 12 inches of the surface, what does that do to your cover crop? So can we change the prescription on that to actually favor cover crop growth? And, what are those trade-offs between losing that water out of the tile line versus having better cover crop establishment? So those are all kind of research questions that are going to be looked into in the near future. Just the cost effectiveness of this practice. Research at University of Illinois, Dr. Richard Cook showed that drainage water management costs about $50 more per acre than the conventional system, and that's both on just the way the tiles are laid out. Thinking about it, how much nitrogen we're removing, right, with a 33% load reduction and that additional expense, it comes out to be about 91 cents per pound of nitrate removed, which once again is very cost effective when you think of nitrate removal practices. That's why drainage water management has been included in many of the state nutrient reduction strategies that are out there, because it is a cost-effective way to reduce nitrogen from the system. Also, once again, I'll reiterate that it's great that this practice is one of the few conservation drainage practices that'll actually has the potential to provide that return on investment to the farmers. Here's what that practice impact looks like, that 33% nitrate reduction. I can see it's a little bit lower than what the saturated buffers and bioreactors were ranked as, but once again, I still go back to this practice. I think should be very attractive to farmers because it does have the potential to actually provide that return on investment. All right, next I want to show another video from our friends at the Soil Water Conservation Society in their conservation media library on drainage water management and the benefits of that. It's always great to have this visual representation of what the practice is. You can see it going in the ground. You can hear from Charlie Schaefer, who's also in the International Drainage Hall of Fame, in this video on his perspectives on drainage water management. So I'm going to switch over my audio here and then get this video going.
Outlet is a creek / dredge ditch. Right next to that, we've got a big control box that we can put basically paddles in to stop the water. If you want your water all out, you lift them all up and get them out, or if you want some water in your lines, you know, you can set it however you want. And then off of that box, you got a 12-inch main that runs all the way up to the next one, which is perforated to the next control box, and that control box basically manages all the rest of the tile in the field.
We want to keep water in the field for a couple different reasons. One is to reduce nutrient loss, which as we look at water quality concerns, we look at the Iowa nutrient reduction strategy, everyone's focused on reducing nitrogen and phosphorus flowing into surface waters from ag production fields. But also we wanted to utilize during the growing season this technology so we can actually make more water and nutrients available to the crop to increase yield. We typically try to install these structures or design systems where the structures are installed on every foot of grade change upslope. So if you think about a main tile line that may be 1,000 feet long and maybe there's 5 foot of elevation difference over the course of that 1,000 feet, then you're going to install a structure or an underground automated float operated water gate valve at every foot of grade change in order to effectively create zones of influence and manage the entire field.
If it's a dry year, we're going to be able to hold back water, and also when we apply fertilizer, we'll be able to shut it off throughout the winter so we're not losing it in case we get a big spring rain or a big fall rain.
The NRCS tells us that in the upper Mississippi River drainage basins, about 30 million acres that we could utilize these technologies on drainage water management.
Oh, I feel like the potential is huge. I think, you know, see it work, it's pretty neat to think that you're on that cutting edge of a better way to do it.
Going into a dry year, you know, we got the tile shut off, so we've got moisture, and we're going to get a better corn crop if we've got moisture in the soil. It'll take time to pay for itself, but I think in the long run, 10 years down the road, I think we'll start seeing quite a bit more come in.
Yeah, once again, those are a great series of videos that SWCS pulled together on these practices, and I know they're happy that we're able to use them in these webinars to help increase the use and the viewership of them. It was really great to hear that farmer point out, you know, starting to think about what to do in those dry years too. When we think about water management, a lot of times, at least in the Midwest, everybody always just thinks about too much water, but those years where it's dry is when it's really important, because that's generally when commodity prices get higher, because yield projections go down pretty quickly. So if we can do something about those dry years, it's going to be very beneficial. With that, we're coming to the end of the webinar here. Please feel free to pull out your phones and scan that QR code so you can take a look at the assessment to see how well we did at presenting the information, to get an understanding, see how well you understood the content matter today. You know, in summary, with this drainage water management practice, we really do think we can see that yield increase, 5 to 10% yield increase. It's best suited for fields with slopes that are less than 1%. Obviously, the whole field doesn't have to meet that criteria, but you want those larger management zones to meet that criteria. Just within the Midwest, there's 30 million suitable acres for this practice. And not only are we going to see that yield benefit, but we also get the water quality benefits of nitrate reduction, 33%. I will recommend people visit transformingdrainage.org. They have a great website describing a lot of these practices. But for controlled drainage or drainage water management in particular, if you go to the Tools tab, they have a map that you can scale in and see if they think areas are suitable for drainage water management. So you can actually, if you have a specific field in mind, you can do that. You know, that's not a final tool, it's more of just a guidance, but it does give you an idea if that practice will work in that area. Thank you for watching this webinar with me. I hope you continue to interact with ADMC. Feel free to reach out by sending me an email. Follow us on Twitter. Of course, you can always become a member to support the coalition. Visit our website. When you visit our website, the first time you do it, within a year, there'll be a pop-up asking you if you want to sign up for our Conservation Drainage Weekly. It's just a weekly e-newsletter that we put out there. It contains some of the latest research on these conservation drainage practices, as well as implementation opportunities for these practices. So if there's new funding available in certain areas, we try to include that in the Conservation Drainage Weekly. And then we do also put the webinars that are coming up, different events, field days that showcase these practices. With that, thank you for completing this webinar today, and thank you to CTIC for working with ADMC, as well as thank you to EPA for funding this. We look forward to working with you in the future.